Beer is a beverage that transcends borders, ranked as the third most consumed liquid on Earth, following only water and tea. Every single day, humanity consumes more than 200 million liters of this fermented gold. But among the thousands of brands globally, few are as iconic as Corona. Today, we are traveling to the heart of Mexico, home to a brewing operation of almost mythical proportions. Corona is a Mexican brand of beer produced by Grupo Modelo in Mexico and exported to markets around the world. It was introduced exactly 100 years ago at the year 1925. Corona Extra has been the top-selling imported drink in the U.S. since 1998. Within these walls, a masterpiece of industrial engineering unfolds, producing an incredible 400,000 bottles of beer every hour. Join us as we go behind the glass and the gold to see how the world's favorite sunshine beer is mass-produced. Step 1. The harvest of gold. Every bottle of Corona begins its life not in a tank, but in the sun-drenched fields of Mexico. The core of the beer is malting barley, a grain specifically cultivated for its high starch content. This isn't just any barley, it is a proprietary variety selected to ensure that signature smooth, refreshing finish. For 4 months, these crops grow under the intense Mexican sun until they reach a deep golden hue. When the moisture levels are exactly right, a fleet of high-tech harvesters takes to the fields. In a single day, these machines can gather 150 tons of grain, a quantity sufficient to fill over 1 million bottles. This raw barley is then rushed to the brewery where the biological magic begins. Step 2. The art of malting. Once at the plant, the barley must be awakened. Raw grain cannot be brewed. It must be converted into malt. This starts with a thorough industrial cleaning to remove any field debris. The cleaned grains are then submerged in pure cold water to hydrate. The hydrated barley is moved to massive climate-controlled germinators. For 3 to 5 days, the grains begin to sprout. This process releases vital enzymes that will later turn starch into the sugars necessary for alcohol. It is a delicate dance of temperature and humidity. Even a slight shift in the outside air can ruin a multi-ton batch. Once the sprouts reach the perfect length, the process is halted in drying ovens. This kilning fixes the aromatic compounds and gives the malt its slightly toasted, fresh flavor. Step 3. The grind and the mash. Now dry and aromatic, the malt is ready for the mill. In the grinding room, massive steel rollers process over 20 tons of malt per hour. The goal isn't to make flour, but to crack the husk just enough to expose the starchy interior. This mixture, known as grist, is the foundation of the brew. The grist is moved to enormous mashing tubs where it meets hot water. In this warm bath, the enzymes activated during malting go to work, converting the starches into a sweet amber liquid called wort. This is the moment Corona leaves its solid state behind, transitioning into a liquid full of potential. Step 4. The alchemy of hops. The wort is pumped into towering stainless steel kettles for an intense, hour-long boil at 100 degrees Celsius. This serves 2 purposes. It sterilizes the liquid and concentrates the sugars. But the real star of this phase is the hops. Hops are added with surgical precision. These flowers provide the bitterness that balances the sweetness of the grain and act as a natural antibacterial agent, ensuring the beer stays fresh for over 6 months. The aroma during this phase is so powerful it can be smelled nearly 300 meters away from the facility. After the boil, the hopped wort is flash-cooled in seconds to prevent oxidation, readying it for the most critical ingredient of all, Step 5. The 7-day transformation. In the fermentation tanks, the beer truly comes to life. Master brewers introduce a specific strain of yeast that feeds on the sugars in the wort. Over the course of 7 days, this microscopic fungus produces two things: alcohol and carbon dioxide. Throughout this week, automated sensors monitor pressure and temperature with total accuracy, while technicians perform constant taste analyses. By the end of day 7, the liquid is officially beer, but it is young and needs time to mature. Step 6. Maturation and the perfect fizz narration. The young beer is moved to maturation tanks where it is chilled to a biting -1 degree Celsius. This extreme cold causes any remaining particles to settle at the bottom, clarifying the beer naturally until it is bright and pure. Before it leaves the tank, the carbonation is adjusted. While the yeast creates natural bubbles, the factory uses precision injectors to ensure every bottle has the exact same level of effervescence and that iconic creamy foam. Once filtered one last time to remove every trace of sediment, the beer is finally ready for the world. Final step, to the global market. The final act is a ballet of automation. 400,000 bottles an hour fly through sterilization, filling, and capping. Each one is vacuum filled to keep oxygen out, preserving that just brewed taste. Labeled and boxed, these bottles are loaded onto trucks headed for over 180 countries. From a grain in a Mexican field to a cold bottle in your hand, the journey of a Corona is a testament to the power of modern industrial brewing. In a world that has rapidly pivoted toward digital wallets, cryptocurrencies, and contactless payments, a surprising physical relic remains more relevant than ever. In 2025, while millions tap their phones to pay, the United States Mint continues to operate 24 hours a day, striking billions of coins every year. Why? Because currency is more than just a medium of exchange. It is a physical contract between a government and its people. From the specialized alloys to the high-security facilities in Philadelphia and Denver, the creation of a coin is a feat of industrial engineering. Today, we go beyond the wallet to witness how raw metal is transformed into the most durable objects in your daily life. The heritage of the strike, a brief history. To understand why we make coins this way, we have to look back to 1792. Following the American Revolution, the young nation was a chaotic mess of foreign currencies. Spanish pieces of 8 and British shillings circulated alongside local bartering. Alexander Hamilton, the first Secretary of the Treasury, pushed for the Coinage Act, establishing the U.S. Mint. Early American coins were truly worth their weight. A gold eagle or a silver dollar actually contained that amount of precious metal. However, as the 20th century progressed, the world moved away from the gold standard. By 1965, the rising price of silver forced the U.S. to switch to the clad composition we use today, a sandwich of copper and nickel. Even the penny has a storied past. Originally large and pure copper, it shrank in size in 1857 and eventually became copper-plated zinc in 1982 to save costs. As we stand in 2025, every coin in your pocket is a biological descendant of those first hand-struck pieces of the 18th century, though now forged by the power of modern robotics. Step 1. The heavy metal harvest. The industrial process begins with the blanking press. The mint doesn't start with small bits of metal. It starts with massive 6,000-pound coils of metal alloy. These coils are fed into a machine that acts like a high-speed 50-ton cookie cutter. This machine punches out circular discs called blanks at a rate of 14,000 per minute. The remaining metal sheet, now riddled with holes, is called the webbing. In a closed-loop sustainability cycle, this webbing is immediately shredded and sent back to the foundry to be melted and rolled into new coils. In the mint, efficiency is a religion. No scrap of metal is left behind. Step 2. The fire and the bath. Punching these discs makes the metal work hardened. It becomes brittle and difficult to stand. To fix this, the blanks enter the annealing furnace. In a scene reminiscent of a sci-fi film, the discs travel through an oxygen-free tunnel, heated to 1,600 degrees Fahrenheit. This intense heat softens the metal's molecular structure, but coming out of the fire, the metal is dull and grimy. It is immediately plunged into a chemical quench of water and citric acid. This eco-friendly acid bath eats away the tarnish, leaving the metal with a brilliant mirror-like shine. After a trip through a giant industrial dryer, the blanks are now pristine and ready for their first physical transformation. Step 3. Raising the rim. If you look closely at a coin, the edge is slightly thicker than the center. This isn't an accident. The blanks move into the upsetting mill. Here, they are rolled on their edges through a groove that is slightly smaller than the coin's diameter. The pressure squeezes the metal, forcing it to bulge upward and create a raised rim. This upsetting process serves two critical roles for 2025 commerce. It protects the coin's artwork from wearing down over decades of use, and it allows the coins to stack perfectly in automated counting machines and vending rollers. Now that the rim is raised, these discs are officially called planchets. Step 4. The strike of sovereignty. This is the heart of the mint, the coining press. The planchets are fed into the striking chamber where two massive steel dies, the obverse and the reverse, await. In a fraction of a second, the dies slam together with up to 100 tons of pressure. This force is so extreme that the metal actually behaves like a liquid, flowing into the microscopic crevices of the die's design. For quarters and dimes, a reeded collar also grips the edge, creating those tiny ridges that originally prevented people from shaving precious metal off the sides of silver coins. Today, those ridges help the visually impaired distinguish between coins of similar sizes. Final step, quality and the waffler. Even in 2025, human eyes still play a role. Quality control inspectors use high-definition cameras and manual checks to spot die cracks or off-center strikes. Any coin that isn't perfect meets the waffler, a machine that crushes the coin into a wavy shape so it can be recycled without being spent. The perfect coins are counted, bagged in 2,000-pound sacks and stored in high-security vaults until the Federal Reserve calls. Every single day, the global population consumes a staggering 330,000 tons of pork. It is the world's most widely eaten meat, a staple of diets from the bustling street markets of East Asia to the dinner tables of the American Midwest. But how does a living animal on a farm become a shrink-wrapped loin in a supermarket within a matter of days? The answer lies in the incredible efficiency of modern industrial processing. Today, we are stepping inside one of the largest pork production facilities in the United States. Here, the scale of operations is almost difficult to comprehend, with some plants capable of processing over 20,000 pigs in a single 24-hour cycle. This is a world where biology meets high-tech engineering, and where every second is calculated for safety, speed, and precision. Step 1. Precision farming and logistics. The journey doesn't begin at the factory gates, but months earlier on specialized industrial farms. The modern pig is a product of decades of genetic refinement, bred for a specific balance of lean muscle and healthy fats. These animals are raised in strictly controlled environments where temperature, humidity, and light are adjusted to ensure maximum comfort and growth efficiency. For about 6 months, the pigs follow a rigorous nutritional program. Their diet is primarily a blend of corn and soy, fortified with essential minerals. This consistency is key. If the diet fluctuates, the quality of the bacon or ham fluctuates. Once the animals reach the optimal weight of approximately 100 kilograms or 220 pounds, the logistical challenge begins. Transportation is handled by specialized refrigerated trucks. It's not just about movement, it's about animal welfare. Stress is the enemy of quality meat. High levels of cortisol and adrenaline in a pig can lead to PSE meat, pale, soft, and exudative, which is unappealing to consumers. This is why, upon arrival, the pigs are not immediately moved to the line. They are given 2 to 4 hours in a quiet, climate-controlled resting area to calm down and stabilize their physiology. Step 2. The harvest begins. As the pigs move into the facility, the process transitions into a highly regulated harvest phase. To comply with humane slaughter regulations, the animals are first stunned. In most modern plants, this is done electrically or via CO2 chambers. The goal is to render the animal instantly and completely unconscious, ensuring they feel no pain during the subsequent steps. Once stunned, the bleeding process begins. In an industrial setting, this is handled with clinical efficiency. But notice that nothing is wasted. The blood is vacuum captured and channeled into separate processing tanks. It will eventually be dried and processed into high-protein blood meal, used in fertilizers and certain animal feeds. In this industry, the saying, "everything but the squeal," is a literal operational philosophy. Step 3. Cleaning and preparation. With the animal now prepared, the exterior must be thoroughly cleaned. The carcass enters a scalding tank, a long bath of water maintained at exactly 65 degrees Celsius. After the bath, the carcass passes through a mechanical dehairing machine. Large, rotating rubber paddles and scrapers strip away the bulk of the hair. However, to achieve the perfectly smooth skin required for many cuts, a process called singeing is used. The carcass passes through a wall of flame that burns off any microscopic bristles. Finally, a series of high-pressure water jets and mechanical polishers scrub the skin until it is pristine. Step 4. Evisceration and inspection. Now, the facility enters the clean room phase. The carcass is opened, and the internal organs, or viscera, are removed. This is a delicate surgical operation performed by both robotic cutters and highly skilled workers. The organs are immediately sorted. Hearts, livers, and kidneys are cleaned for human consumption, while other parts are sent to the rendering plant to be turned into tallow or oils. This is also the most critical point for food safety. Every single carcass is inspected by a government veterinarian or a certified inspector. They look for any signs of respiratory illness, parasites, or systemic infections. If a single carcass fails to meet the standard, the entire section of the line is halted and the meat is condemned. There is no room for error when public health is on the line. Step 5. Chilling and fabrication. The inspected carcasses, now split into two sides, are moved into massive blast chillers. They will remain here for 16 to 24 hours at temperatures just above freezing. This serves two purposes. It stops any potential bacterial growth, and it sets the fat. Cold meat is much easier to cut precisely than warm meat. Once chilled, the meat enters the fabrication room. This is a masterpiece of synchronized labor. On a moving conveyor belt, workers use specialized knives and power saws to break the side of pork into the primal cuts: the shoulder, the loin, the belly, and the ham. From the belly, we get bacon. From the loin, we get pork chops. Every scrap of trimmings is collected to be ground into sausage. Finally, the cuts are vacuum sealed to remove oxygen, extending their shelf life significantly. Each package is stamped with a digital code that allows the factory to trace that specific piece of meat back to the very farm the pig came from. Final step. From the farm to the final package, the process is a marvel of modern logistics. It is a system designed to provide affordable protein to billions of people while maintaining rigorous safety standards. As the crates are loaded onto trucks to be shipped across the country and across the oceans, the cycle begins all over again. The next time you see a pork product in the store, remember the incredible journey of engineering and care that brought it there.